Guys, it's Miss Turnbull here with your Thursday video. Today we are talking about the surface area of composite shapes. Now, we've talked about composite shapes earlier in the course. The definition of a composite shape is any irregular shape that is made of more than one basic shape. So when we're determining the surface area for composite shapes, especially for three-dimensional ones, we have to think about what parts of the surface area formula we need to use for each shape that's involved, and whether we are adding or subtracting when putting the formulas together. So let's take a look at three examples from your notes package. The first one looks like this. So when I look at these questions, I ask myself, all right, what is the base shape? And it really doesn't matter what base shape you choose. You could have chosen the half of the sphere as the base shape if you wanted to. I like to choose whichever shape is most whole. So this sphere, or this cylinder rather, is most whole. So I called this one the base, and then we're adding half a sphere. But this circle that would normally be involved in a cylinder is not going to be part of our calculation. So that's why it's put in here as subtracted. So one of the circles from the cylinder is subtracted. So we need to remind ourselves of the formulas for these different shapes here really quick. So the surface area of a cylinder is 2 pi r squared. This represents the two circles, plus 2 pi r h. This is the exterior ring of the cylinder. And the surface area of one circle is pi r squared. So pi r squared for one circle. And then the surface area of a sphere, a whole sphere, is 2 pi r squared. So when we take a look at this, we know we're going to need only one of these because we're going to subtract one of this, and we're going to add half of this. So instead of 4 pi r squared, it's going to be 2 pi r squared. Okay, so when we scroll down here to look at our full formula, it's surface area equals pi r squared plus 2 pi r h plus 2 pi r squared, where this represents the half of the sphere, this represents the one circle on the cylinder that we do have, and this represents the exterior ring around the cylinder. So let's remind ourselves of what these variables are really quickly. So we have r and we have h. And the radius is 1 foot and the height is 3 feet. So 1 foot, 3 feet. And now we can just input our numbers. So surface area equals pi, radius was 1 squared, plus 2 pi, radius again is 1, height is 3, plus 2 pi, radius is 1 again, squared. So now we can put this into our calculators. 1 squared is just 1. So these parts here are going to be just pi. So 3.14 going on for that one there. 2 pi times 2 times 1 times 3 is 18.8495. Plus last one here is 2 times pi, and then we could times it by 1 if we wanted to. Gives us 6.28 ... Now we can add all of these numbers together. So go back in here, we're going to add pi to this number, and then we're going to add this number here. And that gives us a surface area for this composite shape is 28.27. I think this is in inches squared, correct? Feet squared. Good thing I looked. It's always important to double check your units. Make sure you're on the right track. Okay. So again, what we did was we looked at the shape. We decided what's our base shape, what has been added or subtracted to it, to or from it, and then we combined our formulas as necessary. Okay, so let's take a look at another example that just gives us a shape and asks us to figure it out. So again, our base shape here, I've decided the base shape for me is this cylinder. The cone that is on top has been added. There has been a circle from the cylinder and a circle from the cone removed. Okay, we're not going to see this circle from the cylinder, but we're also not going to see the circle from the cone formula. So we need to remember that. So we take a look at these formulas. We've got the cylinder formula right here. We've got the cone formula right here, and we're reminding ourselves of the circle. We're losing a circle from cone, and we're losing a circle from cylinder. So that means that our full formula for this one is going to be pi r squared plus 2 pi r h plus pi r s, because we've lost a circle from each of those. So now we can just fill in our information. We need to know r and h and s. So r is going to be 11 is the diameter, so that's going to be 5.5 is the radius. The height of the cylinder is 13, and the slant height of this cone is 10.5. So now we can just input our data into our formula here. SA equals pi, radius is 5.5 squared plus 2 pi, again 5.5 for the radius, 13 for the height, plus pi, 5.5 for the radius, times the slant height, which is 10. Okay, so let's throw some of this into our calculator here. We'll start with the first part of this formula. So we've got pi times 5.5 squared. I'm just going to do the 5.5 squared first. Times this by pi. Gives us 95.03. Plus, let's do this middle one. 2 times pi times 5.5 times 13 gives us 449.24. And the last one here is pi times 5.5 times 10.5. And that gives us 181. And now we can add all of these together. We've got this one. We're gonna copy this one over, add this one here, and we're gonna add the first one. There we go. Gives us 725.71. This one is in yards, square yards. Okay, let's take a look at a word problem example. It says Jake and his father installed a wall light beside the front door of their home. The wall light consists of a wooden box with a round plastic cover for the light to shine through. Once the wall light is in place, Jake decides to paint the wooden part to contrast with the front of the house. What area will Jake need to paint? Give your answer to the closest tenth of a square inch. Tenths is 1 decimal place. Okay, important for us to remember that. So again, we decide on our base shape. In this case, I decided I want the rectangular prism to be our base. Okay, what has been added to this base? Nothing has been added. But we have had two things subtracted. The circle from this hole that has been cut and the back of this rectangular prism. The back of it is against the house. It's already been installed. We will not paint the back of this wooden box. So that part we'll have to subtract as well. Again, we'll take a look at our formulas. The formula for a rectangular prism, remember we have to decide, okay, what's our length, what's our width, and what's our height? So we go back over here and we label. Okay, I've decided I want this side to be the length, this side to be the width, and then this height here is going to be the height. Okay, so now that we've got that decided, we know we're only going to need one of the length times height, right? Height times length is the front and then the back, but we don't need the back. So we only need one of the length times height, and we're going to have to subtract a circle. So that gives us our full formula of 2 length times width plus 2 height times width plus length times height, only one of these, minus pi r squared, this being the circle. Okay, so let's write down our variables. We need length, we need width, we need height, and we need radius. So length has not been given to us. So instead, we'll just make one. Oh no, this is a square. The front of this is a square. So it's 8. This here is also 8. Easy peasy. Okay, so length is 8. Height is 8. Width here, they told us is 0.5 inches. And then the radius, they gave us the diameter. Again, there are 2 radiuses or radii in a diameter. So that means our radius is 2 inches. So now we can put this into our formula. SA equals 2 length times width. So 8 times 0.5 plus 2. This is height times width. So 8 times 0.5 plus 2, or this is not 2. See, I'm on autopilot. Really important to remember this. So it's not 2, just length times height. So 8 times 8, and then pi r squared. Pi 2 squared. This is not plus though, this is minus. Again, really important for us to remember whether we are adding or subtracting things. Don't just allow yourself, like I just did, to go on autopilot and throw in signs that don't belong there. Okay, so now we can start doing some of this math on our calculator. 8 times 0.5 is going to give us 4 times 2 is 8. This is going to be the same. 8 times 8 is 64. And then this one we're going to throw into our calculator because it has pi in it. So 2 squared is 4. Pi times 4, 12.56. That number continues on. So now we can just add all of these together. So 12.56 plus 64 plus 8 plus 8. That gives us 92.57. And this is in square inches. And what's this kid's name again? Jake. So Jake will need to paint 92.57 square inches of wood. Okay, so these are the composite shapes. Again, really standard steps. What is your base shape? What has been added? What has been subtracted? Remind yourself of the formulas and then construct your full formula using your knowledge about what these formulas represent. then you just plug in your variables and do the math. Okay? Slow yourself down when you're answering these questions. Don't allow yourself to rush. They really require you to pay attention to what you're doing. If you have any questions about these types of problems, then make sure that you are asking your teacher, whether that's me, Ms. Thomas, or a different math teacher. Make sure that you ask your teacher for clarification for some help. If you are in my class, don't forget you can book one-on-one support sessions in the afternoons, Tuesday to Friday. And Ms. Thomas does Google Meets on twice a week at 11 in the morning. Okay, so make sure that you're taking advantage of those if you need them. Thanks for watching, and I hope this has been helpful.